Testing. 1, 2, 3. Testing. Okay. Ladies, gentlemen, everyone, welcome to another week of EECS 404, Game Engine Architecture. It is good to see you. It's a very exciting time. We have our first auto-graded assignment. It is here. We are midway through it. Before we even launched the assignment on Monday, we had a 100% score come through on every platform, okay? So if you wanted to get that first shining 100 glimmering in the moonlight, it is gone, okay? It has been stolen. And this individual is now on to homework 4. I don't know if anyone can stop him. I'm not going to say who this person is, all right? But they can oust themselves if they want to. In any case, all right, the auto graders are now rocking and rolling. You can look at the auto grader dashboard to see what's going on at any moment. I've not seen anyone submit a build in quite a while. So hopefully we are working on the homework. Do not leave this to the last moment. I'm telling you, Xcode is a big pain in the butt at the best of times and the best of circumstances. And that gets exponentially worse as the deadline gets closer. Okay, and the panic starts to set in. So please do not wait too long to get rocking and rolling on that. Okay, so I think you're going to enjoy this first assignment, particularly if you enjoy C++. If you don't enjoy C++, hopefully today we can help you enjoy it a little bit more. Today, we're going to be talking a little bit about a very important topic. We're going to be talking about compilation and compilation pragmatics in particular. It turns out, if you want to get any sort of C++ project building, there are really only 4 questions you need to answer, 4 fundamental questions you need to answer for the compiler and linker to get pretty much any dependency running. And this is going to become a much bigger deal in the homework 5 week, which is just a couple weeks away. And if you're struggling with the getting compilation going this week, it's going to help quite a bit as well. We're also going to do some C++ programming together. We have a short little workshop. For those of you who have not started the homework yet, how many of you have not gotten a build to occur yet? Okay. All right, good. I appreciate your honesty. We're going to get you started, okay? We're going to get you rocking and rolling a little bit today. If you don't know where to start, we'll give you a good place to start. Look forward to that. We have a fun game engine to show you today. Some of you already know a good bit about this engine because you had a chance, though not many of you took it, to use this engine on your homework 1 and 2. This is Pico 8. It is a strange editor for sure. In fact, I can't remember who said it. But I categorized this engine as an integrated engine because it comes with a bunch of tools that make it kind of feel integrated. But in a very real sense, this is a minimalist engine. It's kind of a hybrid minimalist and integrated engine. And I think you'll get a sense for that in just a moment. It is cozy. It is colorful. It is small and fun to use. It is, in some sense, a game in and of itself. It has a lot of very quirky features. If Nintendo made a game engine, it'd have to be this one because it has a lot of stuff that just doesn't seem very necessary at all, but is very fun, okay, and playful. It was created by Joseph White in Tokyo. You can watch, I think, a 2018 lecture on Pico 8. He even describes it as a cozy design space, kind of a cozy, strange engine. It is $15. What a weird business model Joseph chose for this engine. $15 premium purchase, very similar to RPG Maker. You buy it once, have it for life, except for the educational web edition. which anyone can use and appears to be fully featured. So I don't think Joseph was really trying to make a lot of money on this particular product. If that's the case, you do wonder why it wasn't just released for free or as an open source project. But in any case, if you want to get going, you have to press the start button and you have to kind of figure out how this engine works. Let's go. Press start. Look at this. It has this beautiful startup screen. And here we go. We've got a little console, a little terminal, right? So we can type help for help. We can type ls, I guess, to kind of look at what directory we are in. I will tell you, even I kind of get confused by this engine. You know, I use this engine once a year for fun during this lecture, and that's it, okay? And one of the big challenges about teaching a new 3D modeling course is that I put 3D modeling Blender stuff into my brain and the Pico 8 information fell out. But let's see if we can figure out how to make this thing work. It says Control U in code editor for help on the keyword U, tab, topic, CD. Hold on a second, run. Can I run something? How do I get to the code editor? Install demos? Oh, there we go. Okay, installing the demos. Hello.pb. What on earth is that? Syntax error, okay? Oh, P8. Hello.p8. You see, everything is in capital letters. You don't get a choice over the matter. Is it like this? Hello.p8? Unexpected symbol. Who did Pico 8 in this course? How do you switch to the code editor?
Do load. Oh, code editor?
Yeah.
Well,
I've forgotten. I always forget how to switch to it.
you have to do load hello.p8 and then press escape.
Oh, okay. Hello, load, hello, oh, hello.p8. Could not load. Oh, we're in big trouble, aren't we? Okay, this lecture's already off the rails. Oh, wait a second. Help. Oh, look at that. Yeah, GFX, data, audio, system, math, Lua. Okay. Graphics. What? Okay, help graphics. Camera? Oh my goodness. Okay. How did you edit, how did you get into your editor? I was able to do that this last year.
Just press escape.
Just escape. Oh! Okay, all right, thank you. I hit tab. I was one key away. Okay, all right. So when you hit escape, you kind of go from terminal mode to kind of an integrated editor mode. And you've got your cursor, and all of these up here are different little icons for the different editors that you have. What you're looking at right now is the Lua editor. So you can write Lua functions in here if you want to. I forget what exact lifecycle function you need in order to actually make this run. And I forget what the output statement is. Maybe something like hello. But you can scroll back and forth. Pico 8 kind of transports you to a very early era of computing. And in this environment, a few things that are strange might start to make sense. Have you ever noticed that old functions, old C-style functions, are really weirdly named? Like there's a function, I think called CTRLF. It's something, I think it means like C language control file. Very strange names for functions. It's something like this. I might have messed it up a little bit. One of the reasons so many functions are so shortened to the point of being confusing is that on old school machines, you didn't have very many characters in a line. So if you named your functions, your data structures the way that I tend to name things, right? Super lengthy, it's off the line. You literally can't see the full function on one monitor, right? We're going to talk more about some historical aspects of the C language and many of the APIs we're going to use, like SDL and Lua. And a lot of things are going to make sense when we provide the historical perspective on why it is like that. In any case, you have a lot more things than just a code editor. You have a little image editor. And you can see I can create sprites up here, but those sprites are going to go into a bank down here. And so I can kind of make whatever I want, and I can switch between my sprites. I can only have so many. And then I can go to more of a map editor where I can actually use those as tiles. And I can create a little level like this. Very cool stuff. Here's an audio editor. I hope my audio isn't too loud. Are you ready? Oops, that's not the play button. That sounded good. Usually I make it and it sounds bad. Chunky, right? Sounds good. You can change, I guess, what kind of wave. Ooh, I like it. Nice. All right. And then a music editor if you want to, I think, create a bunch of different layers and tracks. Why do I show this all to you? Well, have you ever heard of a game called Celeste? Okay, fantastic. Would you like to play the original? Oh, you've
kind of suffer, but I think my comment is
Oh, okay. I will show it off really quickly because I don't want to spend too much time on it. But the Celeste prototype was actually made in Pico 8, I think during a game jam or something. And here we go. Okay, X plus C. Here we go. What? What? Okay. Okay, enough. The idea is this. You can quickly prototype something in Pico 8, not necessarily because the technology is great and very convenient, because in some ways it's not that convenient to make games in Pico 8. But what Pico 8 does is it enforces restrictions on you. It is an environment that has very hefty, very obvious constraints. And so when you make a project in Pico 8, it is all about that gameplay. You know it's not going to look that great, though Celeste does look pretty great. And so game designers are forced to focus and hone in and find a fun design and good mechanics. And then they can bring it out of prototype form. They can go grab a different engine. In this case, they grabbed a Monogame, and they can make their game and move quickly. Okay, very minimalistic. 16 colors, incredible. 128 by 128 display resolution. In some sense, it's just as opinionated as RPG Maker, but it's very much opinionated toward kind of a hardware constraint, very specific feel from a specific era. And they're not excited to give us a lot of features. You do get Lua Editor, Sprite Background Editor, lots of good stuff. You run programs via the command line. One of my favorite weird Nintendo-like things about this game engine is that they use steganography in order to embed their entire game into a PNG file. So imagine you download an image from the internet, from Google image search, but actually that image you just downloaded is a complete game. And you can load it in Pico 8. So cartridges. Let me see here. They talk about the steganography that they use in order to basically hide the data for a game inside of an image itself. But let me see if I can actually find a cartridge. Well, I guess not. It'd be nice if they could do that. So here's a cartridge, I guess, an image, right? It has a gameplay screenshot showing you what the game's like, kind of Pokemon style. But then if you can actually load this image into Pico 8 and it'll run the game for you, which is very, very cool. One really cool thing as well is that it was written in C with SDL, which is what you're going to be learning as well. SDL just keeps popping up. If you look in the credits of Unity, you better believe you're going to see SDL there. If you look in the credits of Steam, you're going to see SDL. Now, many of these big programs don't use SDL for many things. Often, they don't even use it for rendering. They use it, for instance, for window handling, cross-platform window handling, or cross-platform inputs, which, you know, they don't want to do themselves, so they just let the SDL team do it for them. They're able to compile their C code base with SDL included into WebAssembly / JavaScript via the mscriptum project, which basically will do that. It's part of like the Clang LLVM compiler toolchain. Yeah, all of this has gotten pretty good in the last decade or so. If you have a code base, you can often transpile that into other stuff if you want to. The way I think that Unity does their web builds is you write your code in C#. C# gets compiled, transpiled to C++, and then all of the C++ gets transpiled to WebAssembly. I think that's kind of how it works. I think they have an intermediate language step as well, but I don't know all that much about that. Okay? Anyway, that's Pico 8. It's a lot of fun. Okay? And if you want to kind of take a trip back to an old era, you can tell I like to do that just by the kind of games that I tend to make. You will have a very good time with Pico 8. Okay? All right. How did homework 2 go? Anyone have any anecdotes? I am always hearing in the feedback that's a little bit of an exhausting assignment because, oh my gosh, I just figured out how to do collision detection. I just figured out how to do audio and spawning of enemies and victory screen. And now I got to do that 2 more times? Are you kidding me? Yes?
Did Unreal Engine.
Oh, pain.
27 hours total on this project.
Brutal.
Like, Unreal Engine killed itself like 2 different times. Like half my project just gone. I'm
like, you might as well take EECS 440 so that you can do homework 2 of 404. Okay? Homework. Unreal Engine is very nasty. I think that's in there, isn't it? Don't we say it's hard mode or something in the assignment? So you can't blame us. There you go. Yes?
I thought it was interesting, so I did my minimalist, and integrated the way it was needed.
Okay.
I thought it was interesting that they don't really have, I guess that's to be basic, they don't really have like their own collision detection things.
Yes.
I would think it would be a pretty basic feature for any game engine because any game was going to have collisions. I thought that was interesting.
Well, maybe, right? So you can imagine that like card games don't really need collision detection. And there are many games. If you imagine like Pokemon. Pokemon needs a very simplified form of collision detection. Interestingly, collision detection is one of those things that is very expensive in the most general case. When you say, hey, I've got arbitrary meshes made of triangles, and I want to detect when they collide, and I want to know the exact point they collide at, and how many points they collide at, that's very expensive. But actually, if you can say, my game, it looks gorgeous, but it's a tower defense game, and all of my objects have a square collider, and none of them are larger than this size. If you can have those constraints in your game design, you can do some wild, crazy crap that you're going to learn in homework 6 to make collision detection lightning fast. Okay? Very cool stuff. In general, in game engine architecture, there is this constant tug of war, a very fundamental tug of war between our desire to make an expressive engine that can do anything. It has no limits. It has no constraints. And on the other end of the tug of war, performance. The more general we make our engine, the worse the performance is because we have to handle any case that the game designer could dream up. But if we can convince our game designer to accept a few small limitations, then we can go flying at blazing lightning speed. We can optimize like crazy. So there's this fundamental tension between expressiveness and freedom and performance. And so this is also one of the reasons that a team might choose to go with an off-the-shelf general engine like Unity, not known for being very fast, by the way, or stay in-house, or even grab Unity but customize Unity's source code so it can be more performant. So it's a really interesting thing to think about. Okay, a couple cool submissions from the past that I saw. Right, so this is just some fun stuff. I'm going to add some of your projects to this for sure when I'm done grading. This is someone's home cat, I think, like household cat. I love the victory screens. They're just really, really cute. And the story here is the cat's trying not to wake up, which is basically me every Monday and Wednesday. Sad. Gotta wake up, all right? The sequel to a 494 game, which was cool to see. I think this is a duck game. Yeah, very, very fun. They used 3D meshes from their 494 project. Sad. And you're trying to feed duck as an old man at the park. You're trying to feed ducks with bread. Unity, come on, Unity, hurry up. We don't have so much time here. Come on, hurry up. There you go. You're throwing baguettes. There are ducks coming in. It's a good time. Okay. And the last one, Pico 8 vertical scroller. Very impressive stuff. Has kind of a centipede vibe to it, doesn't it? Right? So there's lots of really cool stuff from this semester as well. I'm going to find some of those very soon. A public service announcement. Your commit messages could use some work, people. Okay? It really could, all right? Please don't get in the habit of just writing commit messages to submit stuff to the autograder. Do try and add some information about actually what you changed. You may regret it if you want to revert back to an old commit and yet you can't quite figure out which one you want and you don't remember what the pros and cons of each one are, okay? So try not to do that kind of stuff. I really like this one right here. This is a good one. So anyway, I do sometimes check and read your commit messages just when I'm bored to see how things are going. So please leave me some fun surprises because teaching this class for the third time, you do desire some surprises, okay? Okay, homework 3 is rocking and rolling. The autograder is hopefully upgraded now. An announcement I didn't put on here, but I put in the Discord, is that how many of you accidentally installed Visual Studio 2026? And you're like, oh no, it produces a game_engine.slnx file. And I need a .sln file, and the autograders can't handle it. Well, the good news is that the autograders have been upgraded. I was here for like several hours last night, and they now use the latest version of MS Build in their compilation process, and they can now handle the game engine .slnx format or the old format. So either way, the autograder will find it, and it should work out for you. But let me know if you have any problems. I will say, when I upgraded my engine to the latest Visual Studio 2026, latest MS Build, right? All the bells and whistles, performance fell by 15%. And I'm like, wait, what? That's not how it's supposed to happen. I will also say that there is something wrong with the instructor solution for homework 3. I'm still trying to figure out what it is because students are already blowing it out of the water from a performance perspective, and I don't think people are even trying. So anyway, I tell you this, don't get cozy, okay? We take it easy on you on homework 3. Homework 4, the performance requirements will get significantly more intense. And I think a lot of people enjoy that element of the course, getting better at their C++ performance. I think it's just something weird I'm doing with inputs that I shouldn't be doing. And I'm too lazy to really go into it and debug it. So anyway, you get an easier homework 3. If anyone's really upset about that, you let me know, and I'll go optimize it tonight, okay? No, I don't like to make things harder in the middle of an assignment. I think next year's class will have to wait for my revenge on homework 3, okay? Okay, any questions or comments on any of this? I will say, y'all are an awesome bunch, very quiet. I think maybe I should make the course more confusing so you're forced to ask more questions during lecture, okay? I think maybe I'll do that. I'll throw some, maybe I'll just go into some of the homework assignments and I'll just delete a line or something. I'll just choose one at random and just get rid of it and see what happens. Why not, okay? Why not? All right, so one thing I want to do today, because it is a very big concern, it's a fundamental concern that people getting into C++ have to face. There's a very classic story where an aspiring young developer decides they're going to hop in. They've heard the stories about C++. It's a scary, difficult, tricky language, and it is. And they want to learn it anyway. But they get in, and tell me if this story sounds familiar. Tell me if you can feel this. You get into C++ and you find this cool library. Maybe it's SDL. Oh my goodness, I remember trying to include that one when I was very young. I wanted to open up a window. I want to have a beautiful 2D game. And you're trying to integrate this library and you get this weird error. It's just not compiling. And the files aren't showing up. The autocomplete has stopped working. Suddenly, you get this thing fixed. And then, wait a second, it's compiling. Yes, it's working. It goes to run, and it fails. The linker now has a problem with your code. And it's just one thing after another, and you say, okay, I quit. I'm going to go grab Unity or GameMaker off the shelf. Has anyone had that experience with C++? If you haven't, there's a good chance that you haven't really tried to build a big project, or you haven't had many dependencies that you've had to bring in to the project. But the thing is, if you can't bring in dependencies, it's very hard to make an impactful, big, meaningful project quickly. All right. I was talking with a student today who told me that they were building a PNG encoder. So like a tool that can create a PNG for you. And do you want to finish the story? Crazy thing you did, because the dependencies were so damn tough.
I mean, I just ended up writing my own gzip version, like implementing it on my own.
Gavin is trying to bring in a gzip compressor library, right? And they're out there, and they're great. But if you don't know how to link with other libraries, if you don't know how to integrate them into your project, then you're in big trouble, okay? And so you said, that's too tough. It's going to be easier to build my own gzip algorithm, right? My own implementation of gzip in my project. What a nightmare, okay? And that's just how it goes, okay? This is a well-known problem with C++. And the committee, the C++ Standards Committee, I believe, has been trying to address the fact that in Python, you can import whatever you want by just pip install and then import at the top of your Python script. Easy as pie. In C++, you must go to war to import anything, okay? And I want to make this process a lot easier for you if I can, because as we're going to talk about in a moment, having these kind of skills, these kind of low-level, in-the-trenches skills, is what will very quickly distinguish you from everyone else on your team. You will become the person that everyone goes to when they have compilation and integration issues. And you will become very powerful as a result. And I want that for you. So, okay, let's talk about compilation. It is a topic, it is a world of angels and demons, okay? When I'm talking about angels, I'm talking about wonderful features that you really don't want to be developing without. Things like syntax highlighting, okay? Where, right, when you build different, you add different variables, classes, functions, right, you get coloration to help you distinguish them all. I'm talking about the killer app feature of any IDE. If you have an IDE but you don't have this, you don't have anything, okay? Code completion. You press dot, you start typing, you get all these wonderful functions. It's literally a part of the learning process, bringing documentation right to where you are typing. Things like warnings. This is what will save you in C++ if you should accidentally introduce some undefined behavior. In this course, we do not allow multi-threading. Your engines will be deterministic unless you have undefined behavior, at which point you might pass the test case this time, but you're going to submit the same code and you're going to fail the test case the next time. That is the sign, the telltale sign that you've got some undefined behavior. An IDE will point it out to you right here. You have a Boolean value that is uninitialized, okay, which means you could be in trouble, all right? These days, sometimes you even get code completion. You get embedded AI help that can help remind you of what syntax might be for a file format you're not used to, like maybe something like this, okay? What file format is this? This isn't JSON. This kind of looks like JSON, but I've never seen this before, right here. Okay, what about embedded version control? So you can know at a glance what files you have changed. You can make commands. You can commit stuff. Very, very nice. But, okay, if you integrate things effectively, you get these wonderful advantages. But this can also be a hellish road to walk because when we get into the world of Visual Studio and Xcode and CLion, if you're on Linux, it is an endless maze of UI with an endless number of features that do strange things that you can't really predict. Okay? The errors in Xcode in particular are awful. Okay? You will very often get errors that just say unknown error and give you no other information unless you know exactly where to click in the UI. I'll give you a hint. You need to click not this big error button that pops up automatically, but there's a small one to the right, which will give you vastly more information about what actually went wrong, okay? Crashes and bloat. These are not usually very fast programs, these EIDEs. They often will crash. Sometimes they'll corrupt your project. There's a reason this course requires you to use version control and make lots of commits in order to submit. It will save you, okay? If you're on Linux, you might be laughing at all this because you just use Vim or Emacs, and you are at peace with the world. It's awesome, okay? You might also say, I'm just going to write like a one-line make file, and we're going to rock and roll. That's it. I kid you not, a lot of students in this course go kind of crazy with their make file. You don't need to do that. My make file for the final project with all the dependencies included is like one line. It's like 2 lines of code. It looks kind of like this, but has more stuff in it. It's not that big of a deal, okay? And you just rock and roll, and it just kind of works, okay? I want to quickly have a side tangent on the nature of challenge. This is kind of a very abstract thing, but in education, and when you are educating yourself and training and improving yourself, not all challenges are made equal, okay? Imagine you're at the gym. One problem you face is attempting to achieve a new personal best lift. This is a very meaningful challenge. You know what isn't a meaningful challenge? Do you know what is a pure waste of time? You leaving your gym pass on the table and having to drive home to get it. Okay, both of these are nasty problems you have to solve. One of them teaches you stuff and grows you as a person. What about gaming? How about reaching a new rank in your favorite multiplayer esports game versus trying to get your laptop to stop crashing, okay? Because you just haven't updated your drivers yet. Okay, what about this? adding an elegant, impactful, fan favorite new feature to your game engine to double its use, versus getting Lua to link properly and stop complaining. Okay, right? One of these is, I think, a little bit more interesting and valuable and educational than the other. You'll learn a little bit reminding yourself of how to get this to compile, but for most students, getting stuff to compile is just banging your head against the wall until it works, or asking a GPT to fix the situation for you, and then you learn nothing. No, I want you to understand the compilation process pretty thoroughly so that you no longer have to actually slam your head against things. You look at the situation, you can solve it very quickly, okay? Over here on the left are meaningful challenges. Over here on the right, you are wasting your time. So we are going to try and spend most of our time on the interesting problems. The more interesting the challenge, the less guidance we'll give you so you can kind of learn it and figure it out yourself. We do not think that you slamming your head against the wall is a very interesting challenge in this course, okay? Getting things to compile. So we provide guides to help you get your code compiling and linking and running. And especially on the upcoming homework assignments, you're going to get guides, you're going to get videos. Please watch them, okay? We have an AutoGrader general guide explaining how the AutoGrader works, but we have Windows, OS X, and Linux Makefile guides as well for you, all right? For Linux, it's going to be very simple stuff, okay? For Xcode, it's going to be a bit more painful, and for Visual Studio, it'll be, kind of painful, all right? IDEs are going to feel very unique at first, but one thing you'll discover is that all IDEs are kind of sort of the same, okay? They're kind of sort of the same. And C++ compilers are going to ask you for the same information. They're just going to call it different things. And that's the key. The first thing you need to do when you are dealing with a dependency in C++, you need to tell your build system or your IDE where it should look for things. In particular, where should it look for the C++ headers that I'm looking for? And I'm going to show you, I think, how to do this with the first dependency very soon. Where should I look for things? Where should I begin my search in your file system? Okay? In Visual Studio, what you do is you right-click on, in fact, you know what? I'm going to just bring this up now. How about we do it? Let's do it now. Visual Studio 2022. You open it up. You want to begin your game engine journey. Here's what you're going to do. Open it up. Go to Create New Project. You're looking for the emptiest templates they got. In fact, it's literally called the empty project. Start from scratch with C++ for Windows. No starting files. Click. I'm going to enter, okay, game_engine. All right. I like to check this little box that says put the solution and the project in the same directory. I'm going to go find my GitHub repo so I can make sure I can put all this good stuff in the root of that repo. For now, I'm just going to create a folder. Let's call it like Game Engine 3. Okay? Right in there. Okay, there we go. Game Engine, create. And we'll give it a few moments. Okay, here we go. Give it a few moments. Give it a few moments. And we're done. That's it. There's nothing here. Well, what do we want to do? I always like to open up a Solution Explorer, which I can find, I think, by going to View, and then it's the first one, Solution Explorer on the right. This will show you your file structure. What I can do if I want to customize my settings, if I want to get to what you see right here, which is, and by the way, a reminder, you can get my screen right in front of you by just going to twitch.tv, /Yarger, and you can be right there, okay? So you don't have to squint. You can also get closer if you want to, if you can't see very far. But what you're going to do is you're going to go in and you're going to right-click on this game engine right here, this property, this project name. Go to Properties. We now have access to all of our configuration. Look at this. for the Visual C++ compiler, VC++, that is like Microsoft's compiler for C++, I click on VC++ directories, and I have all these options. I can tell it where to look. Where are those header directories? Another name for that is include directories, okay? I can look in here. Whenever I write some code like include, include header.h, these directories are where it's going to look for that header.h, okay? That's where it's going to start looking. I need to create a file here. So let's go to right-click here. I'm going to click on Add. I'm going to go to, how about a new item? And I want to have myself main.cpp. Okay? Whenever you add stuff to your project, make sure you do it this way, right? Don't just kind of throw it in willy-nilly. You want to right-click and then go Add and find what you want in here. You want a new class. You want a new C++ file. The reason you do this is because if you throw it in willy-nilly, Visual Studio will just kind of like ignore it. Like it's there, you can see it, but Visual Studio is not tracking it. It might not consider it part of the C++ source code. It might not hand that file to the compiler. And that's going to be very confusing. You're going to see the file, but for some reason the compiler isn't getting the file when you go to build. This way, Visual Studio knows about your file and what you're making. It's going to hook everything up for you really nicely. Okay, let's go ahead and include some stuff. Here's a little bit of trivia that you will want to know for the exam and maybe an upcoming quiz. Okay, what is the difference? Have you ever seen this? You've seen things like, is it IOStream? Yep, there you go. I've got so many languages in my head. I'm thinking like, oh man, wait. It's something different in C#. Right? What is it in C++? Okay, I guessed right this time. You've seen include IOStream, but you've also seen include cool library.h. What is the difference between these two lines? Do you know? It's actually kind of important. Okay, and I think there's a little bit of varying behavior based on the preprocessor, based on the compiler. Yes.
One of them is supposed to be for the entire. One of them is supposed to already exist on your operating system. The other is supposed to be in your repository.
Yeah. So what's happening is that when you use the carets, this usually means, hey, go look in the centralized system repositories for these libraries. These are system-wide libraries. Usually they're installed like with the system. Or, when you install Visual Studio, it'll install all of these. Okay? So libraries that you didn't install, that came pre-packaged, pre-included, are going to be in these carets. And these carets are telling the preprocessor, hey, go look in like the central core system locations, like the weird, /user/bin folder. Okay? All the real spooky stuff. Now, this, with the quotations, are usually for your own headers that you make for your project, or maybe for a small library that you just kind of brought down and put in your local project folder, okay? So this stuff is local and the carets are global. So that's why when we refer to really classic things that everyone's got, like IOStream, we always use those carets, okay? In any case, I need an int main real quick, and I should probably, if it's going to be an int main, I should probably return a number. That makes sense for us. I think there's also, oh gosh, what is it, argc? Int argc, and char star argv. Yeah? Is that it? Did I get it right? Okay. I forget this because I never think about it. I think about the first time I start a project, okay? What's it?
2 stars.
Oh, 2 stars? I think this is an acceptable alternative, isn't it?
Yeah.
We'll see if this compiles in a second. Okay, everyone, the reason you want this, oh, yeah, don't you dare do this. Don't you dare, okay? Don't you dare. How many of you have done this? Yeah, of course you have, right? I do this all the time. Don't you dare do this. Because when we add SDL as a dependency to our project, it is going to do some very strange magic to basically sub in SDL's own version of main so that it runs instead. And it's going to fail to do this if you have this version of main. It's expecting you to have this more classic version of main, okay? So anyway, just do this. And I think actually the compiler might, the autograder might yell at you if you do the version of main that doesn't have any function parameters. Anyway, okay, we are trying to get this thing to compile. And look at that. I think it's going to compile all right for us, hopefully, okay? Hopefully. I want to go grab a dependency. Okay? We're going off the rails a little bit. And let me see, 404. 404, oops, that takes you to my planning document, so don't do that. Let's go to 498. I was originally going to name my MMO architecture course 404, so that's why my 404 shortcuts takes us there. Let's go grab the dependency that we need for this homework, okay? Let's go grab the dependency, all right? And I'm going to go down here this box. I need GLM, a header-only library. We are in luck. Header-only libraries are the easiest to integrate. And so let's go ahead and grab that right there. I'm going to go grab that, and let's get in here, okay? And let's zip this, unzip, get some 7-zip going on, okay? And so I've got my project folder. How can I easily get back to my project folder? I can right-click at any time, and I can go to Open Folder in File Explorer. Boom, I'm right there where I want to be. Now I can go and I can grab this good stuff right out of here, and I can unzip it. Actually, wait a second. I grabbed the zip file, so I don't quite want that. Do it? Well, I can just unzip it here, I guess. So let's go ahead and unzip it right here. Get it out of here, okay? What I like to do is I sometimes like to have a third-party folder just so I can kind of keep track of what is mine and what is not. And often, the folder will come with all this like version information in here. I don't like that. I'm going to grab the inner folder, GLM, and I'm going to bring it out and paste it into the third party. So now I have this beautiful situation, third party folder, GLM inside of it, and a lot of stuff in here. We've got some testing stuff. I don't need any tests, so I'm going to delete that. I don't need any documents. I don't need CMake. I do need GLM, which is right here. And you know what? I actually don't need any of this stuff either. I'm going to take this folder. I'm going to copy it. Actually, I'm going to delete the rest of this. And then I want this folder right here, so I'm going to paste it right here. It's going to, did it? Okay, yes, good. So now we have this folder structure. Root, third party, GLM, and all the goodies, okay? So you want your folder structure to be clean and nice. There are going to be things in there you don't need. And so you're going to want to pay attention to what's actually in your project. I'm going to delete this folder. You also want to know where your main.cpp and where the root of your project is, because that's where our header includes need to be written kind of relative to. Okay, so let's go back to our presentation really quickly. All right, we need to answer the question, if we want to include anything, of where should my compiler look for the headers that I ask for? And so, where should it look? What do you think? Here is our project. Should it start to look for our resources, our headers in here at the root? It's a decent place to look, okay? So that's one place we might want it to look. That's reasonable. There are lots of answers to this question. Let's go into properties, and I'm going to go to Visual C++ directories, include directories, headers directories. Okay, very good. Let's look at what it has. I wish I could make this bigger for you. But look at, by default, it is going to look, the compiler is going to look, the preprocessor, to be specific, is going to look in all these places to find a header for us. Okay? Where is it not looking? I don't see any header in here that looks like the root of my project. Do you? So here's what we got to do. Let's go in here, and I am going to put in the path to our project root, okay? But I'm going to do it in a clever way. I'm not going to put the raw address in. I'm going to put project dir, and I'm going to hit enter, okay? This is a macro, $, open parenthesis, project dir, close parenthesis. And you can see when I hit enter, look at this evaluated value. Look at that. If you're squinting your eyes, like please just kind of roll up here, all right? It's worth it, okay? I promise you. Look at that. We now automatically have C users AY source repos, Game Engine 3 Game Engine, okay? Perfect. That is literally the folder. I can check it right here. Do you see this? I can check it. And we can see that it's going to look for headers in this folder. But do you see any headers in this folder? No, you don't. Okay? You don't see any headers in this folder. And you know, that's a little bit of a problem. So, where should I look for headers? Where's a good place to look? Let's say that I would really like to write this beautiful code. Include glm.h. Wouldn't that be amazing code to write? I should be able to include this file. The file exists. I go into third-party GLM, and let's look for glm.h. Did you know you can click inside of a folder, click on a file, and then just type glm, and it will take you right there? Pretty cool, huh? HPP. Yeah, this is an old library for sure. You don't see that extension too much anymore. We should be able to write glm/glm.hpp. And it doesn't work. What's the problem? Well, the problem is that our preprocessor is looking in all the wrong places. Okay? This path only takes us to a valid file if we look in a very certain place. Currently, our preprocessor is going to start looking in this root folder of our engine. It's a good place to start, but here's what happens. The preprocessor is going to go into this folder, and then it's going to go along this path. So tell me, okay, we have to find the GLM path. Where is it? Tell me in here where you see the GLM folder. It's not finding the file because it's not looking in the right place. It's starting its search in here, but we don't want it to start its search in here. Where should it start its search?
Third party.
Bingo. Let's go into the third party. Suddenly, wait, I see the GLM folder. And if we find, so this part of the path works. So let's try the next part. We go in, so let's go in, and now we're looking for glm.hpp, glm.hpp, bingo. Here's the problem. We failed to tell our preprocessor, our compiler, where it should be looking for things. The file system is big. The hard drive is huge. It can't afford to look the entire hard drive for that file you want, okay? It's going to look in a few default places. And you can see those default places right in here. Go to Properties, right-click Properties, C++ Directories. Include directories. We got a bunch of them by default. There's a lot of good stuff in here. That's where like IOStream is by default. But where's the third-party folder? I don't see it in here. So what are we going to do? What should we do? Any idea? Yeah, let's add it. Let's do it. Okay, let's do it. So, by the way, where did my last one go? Do you know where it went? Why is it doing that? Very strange. One thing I want you to do is right now I am editing the properties for the debug configuration. This is a big problem. Debug is awesome because it is, makes debugging easier, but release is what will run on the autograder. So what I like to do is I like to switch to all configurations. Now I'm editing all of the properties for all the configs. Very nice, okay? Okay, let's add a macro, all right? I want you to always search $ in the project directory / and actually it's Windows, so I do the weird / in the other direction. And then what is that folder that we want to start our search in? It's called third_party. Please never put spaces in the names of anything, okay? It makes your life hellish. Third party, enter. Look at this. Oh, actually, I messed up. You see there are two slashes now. So I actually don't need the / after this. I get rid of the /, boom. Look at that beautiful place to search from. Okay? I hit OK, I hit apply. Don't forget to do that. And oh my goodness, look at that. Is that beautiful or what? Like a breath of fresh air. It's like a cold drink of water after wandering the desert. You know the feeling when you've been banging your head against the wall to get something compiling for like what feels like a day. And suddenly it all clicks. And now I start typing and oh my gosh, the autocomplete is working, okay? glm.hpp, oh my goodness, I got included. And now I'm gonna start to write glm and it's working and I've got my wonderful integer IVEC2 and I've got a 1, 2, and I'm gonna, oh my goodness, this is just amazing, isn't it? Just incredible. It's perfect. Yeah, it's looking really, really, really good. And so we've answered that question. All right, back to our lecture slides. We answered what might be one of the most important questions for the compiler. Where should you look for things? If you mess this up, you're going to be typing all the right include statements, but it's not going to find what you need. It can't look all over the entire big, 2 terabyte file system disk, okay? You got to tell it where to look. Okay, but you have to tell it other things as well. All right? In Visual Studio, you go and do exactly what I just did. But you need to do this on all the other build systems too. It's universal. The only thing that will change is what it looks like. On Make, on Linux, when you make your Makefile, someone, I think Maxwell, said that, actually, I didn't know this, you can have a lowercase Makefile name. You can have a Makefile with an uppercase, and you can also have like GMU Makefile. I did not know that was the case at all. That's really funny, yes?
Actually, when I submitted to the auditor today, my Makefile was a lowercase m, and the auditor was complaining about it. So.
Yeah, exactly. Well, my autograder thought that the only standard was capital M.
And the funny thing is, when I changed it to an uppercase on my Mac, which is a case-insensitive file system for some reason, it didn't pick it up. So I just changed it to uppercase again.
Wow, that's wild. Yeah. Okay.
Sure,
I think for the next autograder upgrades, I'm going to allow the other 2 names for the Makefile as well. It's really cool. Anyway, in a Makefile, this is the way that you specify a place to search for stuff, okay? It is -I, and then you don't put a space or anything. It's a very weird way to provide parameters. But -I, and then everything that follows needs to be a path, and that path is going to be one of the places that the preprocessor is going to look if you do that include statement, okay? So it looks different, but it's the exact same idea, and that's the important thing, because there are going to be more IDEs in the future, but they're all going to ask for this kind of stuff. In Xcode, it's kind of sort of similar to how Visual Studio does it, in that you're going to have to search for a search path, okay? Header search path, not include, but header search path. And then you're going to have to provide a list of places to look. And you're going to want them to be relative to the project. Because here's the thing, okay? If you have this big and nasty file path that you've configured into your Visual Studio project that includes your unique name in the path or your username, on the AutoGraders file system, you don't exist. So that file path is going to fail. And you're going to be confused as to why it's failing. It builds on my machine, right? It only builds on your machine. Okay. Right now, I'm investigating Docker and containerization because the age-old problem of it works on my machine is a problem that containerization is kind of designed to try and solve. And it's a very big deal when it comes to back-end development and web dev and server dev. So, you know, we take that class, we get to learn about containerization, which is very cool stuff. Use relative paths. Do not hard code a path. Certainly do not type in your unique name ever to these paths. On Visual Studio, you can use Project dir. On Xcode, you also have the same macro, except you have to use an underscore. It's like they were so close, you know? They were so close. They should have talked. Okay? So the first problem you need to answer is, where do I look for things? And the second is you have to actually say, okay, I know where to look, but what do you want? Okay, and when I write this include right here, I am answering question number 2. If I try and use, let's see, GLM IVEC 2, okay? Or how about my position, all right? And wait, I forget. Can I do something like this? Is that a thing? Yeah, that's a thing. The syntax differences between languages just drive me a bit crazy, okay? This is going to build, I'm pretty sure. Let's see if it builds, okay? I don't want to get too cocky. All right, it builds, great. What if I told my compiler where it should look for headers, but I forgot to tell the compiler which ones I actually want? You get an error like this. We've configured our search paths, our header paths, our include paths properly, but we have yet to actually make a selection. Okay, we've got the menu, but we haven't chosen a dish. So this include statement is where you're actually telling the processor what you actually want. Okay, wait a second. Why is it angry at me? Hold on. We got a situation. Include. Okay, GLM, good, okay. Sometimes your IDE just needs a few moments to kind of catch up to what you're doing. So if it does unexpected stuff, just give it a few moments. Maybe it will correct itself. We've now answered that number 2 question, okay? And if you can believe it or not, that's kind of getting close to being it, okay? We need to tell our compiler not only where to look for things, but also what we want to use. And so this is where you have things like this. The preprocessor will look for these files and look for these paths based on what you specified in that step number 1. Yeah, you now know the difference between these two things. Keep that in your back pocket, okay? Tell it where. The third thing you might have to do is that you won't always have a header-only library, okay? We're now done for homework 1. We included GLM, we're golden, okay? You also have to include map helper, but it's the same exact process. So what we're going to do is on homework 5, in just a few short weeks, you're going to be including SDL. That's your first big nightmare test. It's going to be okay. You're going to make it. We have videos. Literally just watch the video and follow the video. But in much the same way that you dealt with headers, specifying where to look for them and which ones you want, for libraries, which are typically, pre-compiled things. They're big binary blobs. They're not human readable. You need to tell them where to look for those libraries, because there are a bunch of default places to look for libraries. They're going to look there, but look at that. Library directories is right below include directories. All right? It is right here, okay? And you can do the same exact thing. Okay, if you've got a library in your repo, then you can include it. You can tell Visual Studio where to look at it from there. With make, you don't use -I, you use -L to specify where libraries should be found and looked for from. In Xcode, you have right below header search path, library search path. Exact same principles here, okay? Nothing special about it at all. And then, in the same sense that you have to tell it, okay, we know where to look for headers, which ones do you want? Well, we now have told it where to look for libraries. Again, which ones do you want? Do not forget to do this, okay? When you go to the Linker tab, this one's a little bit harder to find in Visual Studio. When we go to the Linker tab, there's this little thing called Input, and there's a little area called Additional Dependencies. And this is where you will specify, oh, I want SDL main, I want SDL image, I want SDL mix for the audio mixer. You'll specify these libraries here, and that will tell the linker that you actually want to use those things. Not just look for them, but use them. Okay. Have you ever did this before? You type -l, then you have to write usually a few capital letters. What is happening here is that this isn't actually the name of the library. -L is a command saying the following is the name of the library, okay? And then the latter part is the actual library file name. And you can find, I think it's actually called libstl2 on Linux or something. There's like a little prefix on it. I think that differs based on what platform you're on. But this, with make, is how you specify, okay, now actually link with these libraries. And you're going to get a very particular error if you don't do this, you forget. This is part about how why we can usually solve your linker issues pretty quickly if you bring them to office hours. For Mac and OS X, it's a little bit of a nightmare. You have to go into the build phases portion of your project through this nasty UI, and you have to find what are called framework files. These are kind of your libraries, and you have to go in and hook them up. If you put them into your repo, which we do require, unfortunately, for technical reasons, we require it for the autograder. If you clone something down from the cloud, it will have weird permission issues probably. And there's a script we have for you that you can run in the terminal to fix these permission-related issues so that things actually run again and they actually work. It's a bit of a pain. The autograder does this automatically. I've had students who have said, Austin, I can't get this darn game engine to build and run on my Mac, but it runs on the autograder. And so I just test everything by just submitting constantly to the autograder. Okay, well, you can do what you want to do, but that's usually what the problem is. There is a final step for most, for many C++ dependencies, where you might have a DLL. You might have a file that is going to get linked dynamically by the operating system at runtime. That is a feature that most operating systems provide. It's kind of interesting, right? So you have these DLL files that often sit in a central place, and programs, many different programs might use that same DLL. And so the program will start running, and the operating system will go, oh, this program needs this DLL, and it'll kind of patch it in and hook it up at runtime. So if you have a build that succeeds, but when you go to run your engine, it explodes and fails suddenly when you go to run it, a good chance we messed up the DLL situation. So in the future, we're going to use it's called a post-build event to copy DLLs into the correct location near our executable so that they will run and find the DLLs properly. Yeah?
For later, will SDL on Linux be static or dynamic?
I think SDL on Linux is statically linked. Okay? All right. Cool. So yeah, post-build event, you're going to do some like very basic stuff like this to make sure the DLLs are copied to the correct directory where your executable will end up so that they run properly. Okay? In Xcode, you often have to configure this. It's called the R path. Very annoying stuff. Okay, so we want to categorize these issues if we can. There are two common issue types, and this is stuff that will absolutely show up on the final exam, and it's going to come up on some quizzes as well. I love how I say final exam, and everyone's like head snaps over here, right? Actually, it's not a final exam, it's a midterm exam. It's just a fairly late one. Compiler issues and linker issues. Compiler issues are where we are trying to understand our code and the compiler just can't figure out what the symbols we're writing, what the words we're writing actually mean or what they reference. Okay? You might write a function call called weird function call. It's going to say it's undefined. We can't actually find a function called weird function call. It hasn't been declared. Okay? It has not been declared at all. Compiler issues usually occur very early in the build process. It's some of the kind of the earliest stages of the compilation process. Linker issues tend to look like this. In Visual Studio, at least, the error code has a nice LNK in it to give you a hint that you messed up something to do with the linker, okay? Which probably means you messed up your static libraries. Library-related paths or includes have been messed up. Okay, compilation issues are usually header-related problems and things you've messed up. Okay, it says there's an unresolved external symbol, which means we know about the symbol, but we never really got the implementation for it. It was declared, but we can't figure out what this function actually does in its guts. Okay, we couldn't find the guts of something. This usually occurs later in the build process, and then DLLs occur super late, like when you literally go to run the program. Okay, so to fix, right? With compiler issues, you want to tell it where to look for headers, and you want to make sure you're including the correct ones. Many third-party libraries have very specific header files you are supposed to include, okay? Look at this right now. What a pain in the butt. Okay, there is a lot of really cool looking and cool sounding stuff in our GLM library. Look at all these great files. We could include a matrix. We could include geometric.hpsp. Doesn't that sound great? Okay. You usually don't want to include that stuff individually. A library will make it known, buried in its documentation, usually, that thou shalt only include this file. All the other ones are there to kind of like be included in a cascading way. So you have to be very, very careful. There are a few libraries that will blow you up if you accidentally include something that you think would make sense but doesn't end up working. Okay, you might need to adjust your includes. You might be including the wrong thing, or you might be missing an include for a certain piece of data that you need. For linker issues, once you've identified that, oh, I've got a linker issue, not really a compiler issue, but a linker issue, you probably need to adjust your IDE's library directories config, i.e., where are you looking for the libraries? You're not finding the libraries, you might not be looking in the right place, okay? Or you may be looking in the right place, but you're forgetting to tell your build system which libraries to actually use. It can't just auto-detect which ones you want, okay? A lot of this stuff, a lot of these problems were sandpapered away by languages that came later, like Python, okay? Which was kind of designed to be very nice to use and very beginner-friendly. C++ is not designed to be nice to use or beginner-friendly. Its overriding priority has been, right, efficiency, power, control, transparency, okay? Nowadays, they're trying to kind of correct their mistake before languages like Rust come and eat their lunch, okay? Like they've kind of seen, all right, UX does kind of matter. So they're working on it, but here's the big thing. You never want to give up. You're going to run into a lot of problems and pain getting stuff to build in this course. And I want you to know that getting past this is going to make you really special. Okay? Soon, you're going to feel good. It's going to feel good to just like see an error, know how to fix it, immediately fix it. And it works, okay? That's going to be a great feeling for you the first time it happens. It might not happen for a little while. You're going to need some practice. You're going to need some help, some videos you're going to watch. But look forward to it, okay? Because it's a very powerful feeling when suddenly you can include basically anything you want. In the final 2 weeks of the semester, guess what? You need to include projects that I've never even heard of. You're going to be doing research work. You're going to be integrating libraries. Who knows what library you're going to want to use? And students never ever have a problem with it. Okay? I have yet to hear a complaint. I couldn't import this library at the end of the course. No, students can just do it. It's a superpower. It's not sexy at all until you have it. All right? And then everyone wants you to help them. It gets a lot easier. Soon you'll be that cool teammate who can fix all of the integration and build issues. And you can start grabbing whatever weird projects you find on the internet that you want. It's a pretty good time, okay? So, speaking of that, we've got a little bit more time. And so what I want to do is I want to kind of give you a little bit of a, starting ground, okay? What I would like to do, and I have to kind of remember this from scratch. I didn't have quite enough time to do prep as I want. Last night was a no-sleep night for me, not because I was working late, but because my sleep schedule got out of sync. And so I woke up too late on Tuesday, which means it was not possible for me to sleep at the correct time Wednesday morning. So rest in peace. But here's what I'm thinking I want to do, all right? I want to launch my game. I'm making a game, and then we turn that game into a game engine by generalizing it in future homeworks. But right now, I just want a game, all right? And I'm going to do this. I'm going to right-click. I'm going to go to Add. I want a class, okay? I want a class. I'm going to call this my engine, okay? This is the start of my engine. I'm going to click OK right here. Now I have my engine class in the form of two files, a header file and an implementation file. They are now in two different locations, header files folder and the source files folder in here. And what I want to do is I want to design my class. I want to design what's going to be in here. What kind of functions do I need? In a header file, we care about declarations. We are making a declaration to the heavens that we have certain functions, we have certain pieces of data, certain variables. Now, we don't really worry about how they're going to work, how they will be implemented yet, okay? That's the implementation. That's what happens in a C++ file. Okay? One of the reasons that this kind of separation is made, keeping your declarations away from your implementation, is that you can often distribute, one of the reasons is you can often distribute the header files to help people out as documentation. But you often don't want to distribute the C++, the .cpp implementations. That's proprietary. That's your secret sauce. Okay, you provide those in a binary kind of form, a library form. Okay, in any case, we would like to have some information. I'm making a text adventure game, so I would like to have a vector2 to keep track of where I am. All right, so I don't have access to GLM. I know that because I type GLM and nothing comes up in my autocompletion. We got a big problem. Well, in this file, I need to know about that GLM library, okay? And let's just give it some time to catch up. Okay, there we go. The autocompletion is working. glm.hpp, boom. Now, suddenly, my autocompletion knows about the GLM namespace, and I can go get that integer vector 2, ivec2. And I can, what can I call this? I can call this position, okay? All right, why not? Okay, in a game engine, a typical game loop goes something like this. First, we want to get input from the user. We then want to update our game state based on that input and other things happening in the game. And then we want to render the final result of that frame, of that update loop. So the very classic pattern is something like this, okay? Void process input, void update, and then void render, okay? You can kind of think of it as just input, update, render. It's that input, update, render loop. I think I got this in the right order. You can sometimes see engines mixing it up, but I've created these functions. But you know what's really, you know what these green lines are? These green lines are telling me, hey, you say that you have these functions, but I don't see any of these functions, okay? I've got a declaration of the function, but I haven't made my function yet. So here's a really fun thing. It's so nice to code in C++ when you know your IDE well. So here's something you can do really quickly. Right-click, okay? And then I can go to Quick Actions Refactoring, create that function for me. Boom! It just created the function for me. And I can do it for these other ones as well. I can right-click, create, okay? Boom! Now I've got that function. And I can come back and I can do it here and just give me that function right now, and boom. You can see that the errors have gone away. Everyone is happy. And let's go ahead and actually, I need one more function, okay? I need one more function. I need the void game loop. And I've got that function here, and I'm going to go ahead and have Visual Studio generate that nicely for me. In our game loop, we will usually run until the game has ended, okay? How do we know when the game has ended? Well, we might want to use a variable that we can flick off to end the game. So let's add one more variable here, okay? This is for player state. This is kind of like game state. We can have something like a Boolean running, like, yeah, running, or game running. Okay? And we'll start that off as true. In this implementation, right, we can go while the game is running, we will get input, we will update our game, and then we will render that game. Okay? And there we go. Let's really quickly make sure that we're entering this game loop by calling main here. Or actually, let's create an engine. Let's go ahead and create an engine. Engine. Oh my gosh, what's happening? My engine data type. I worked so hard on it, I can't use it. What's the problem? It's a disaster. Yes?
You need to include that.
Oh yeah, I need to include it. Okay, I gotta include, just like I'm including the third-party GLM library, I gotta include my engine.h. Okay, there we go. So now I can go engine, and I can actually call into that, let me see here, dot, hello. Is it not happy? What is it? Engine declared inaccessible. I made a big mistake. I forgot about accessibility. In C++, it's a little bit weird. And I was writing a lot of C# code today. In C#, we just do something like this. In C++, you do it like this. Okay, you just kind of define a whole section, so you don't have to write it 4 times for 4 functions. Once, and everything below it is public. I actually don't want this, okay? Input, update, and render are handled within the game loop internally to the engine. So I'm going to put these up here to make them private again. And now, let's see what I can do. I go back to my main function. Let's go game engine. I press dot, boom, it finds it right away. Okay. That was actually a good compiler error message for once. It told me exactly what the problem was. Okay, this is going to be an infinite loop because there's nothing in my game that ever flicks running to off. We need a way to actually deal with input. If you think about input right here, what it should probably do is it should probably return something, shouldn't it? Okay, it should probably return a string. Look at this. My autocomplete can't find string, which is a strong hint that I'm not telling it to actually use string. Okay? So I include string, boom. Now suddenly autocomplete finds my string data type, and now this function needs to return a string. I'm gonna just kind of put this up here, just a stylistic thing. Okay, actually no, I won't do that. All right. Okay, so what kind of string will we return? I always forget which way the cin and cout goes. Let's go result, string, result. I'm gonna type a little thing here, standard cout. I wanna go, please enter a command, east or west, okay? And then standard end line, oh, I got a little typo. Okay, is this good? Is it angry with me? Oh, count, what? Cout. And if it didn't like cout, it's because we need that IO stream. Okay, there we go, include. There we go, sweet. Okay, please enter this. Now I think what we do is the opposite, right? No, we do cin. So standard cin, and then we're going to put this into result, and we just return result. Okay? Right, there we go. Now it's angry at us. Why is it angry? Does anyone know? Bingo. Yep.
Because you called it a void in your header file.
Exactly. So you got to remember, if you update the signature, then you need to update. If you update the signature in the implementation, please update it in the declaration as well. So now we've got this little message, and what we're going to do is we are going to, you know what I like to do, actually? I'm going to do it a little bit differently. String last user input. And it's going to start off as 0. I think I can do that. Yeah, I can. I'm going to actually keep this as void. And what I'm going to do is I'm going to set that value. Instead of having this result, I'm going to say, hey, just put it into last user input. Boom, not going to return anything. Now what I can do is in update, I can check, hey, if last user input was equal to E, then I want you to take the current player position. What is it called again? It's just called pose. And by the way, can I initialize this? Can I? Can I do something like GLM? Is it going to let me? I don't know. Let's see here. 0, 0. Is it going to let me? I always forget. Oh, no, it's not. Oh, it will. It has a different issue. Okay, great. Okay, so position, right? Can we plus equal a GLM IVEC? It's going to be 1, 0. So moving to the right. Can we do this? No, it doesn't like that. Oh, it doesn't like that. So, 2. It needs to be 2. Bingo. There we go. Else if last user input, for some reason it doesn't like that. It's very sus, very suspicious. We are going to minus equal it. Okay, there we go. All right, sweet. Actually, I should probably just make that a -1. That's a little bit nicer. Okay, so now what I'm going to do in render is I'm going to have just a very, very simple render situation. I'm just going to print what position we're at, okay? X versus Y. So let's go ahead and do cout current player position. Do you know if C++ has the amazing replacement strings? No? Oh, that's brutal. All right. C# has spoiled me. Current player position. I'm just gonna kind of piece it together like this. Let's do position.x. Oops, .x. Okay, and then we'll do position.y. Okay, and then we're done. All right. Go ahead and new line it, flush it, and then we'll move on to the next one. Let's go ahead and run this. However, I want to do one last thing. If the last user input, not sure why, I'm very suspicious about that, why that autocompletion is failing. If it's equal to quit, then what we want to do is we want to set that game running variable to false. If we set the game running variable to false, then as soon as we're done with that final render, we should exit the game. And I can actually have a message, okay, to denote the game has ended, and we can rock and roll, okay? And I'll also put one in here just for good measure. Okay. All right, we've written a lot of code, so we should actually test this thing. Oops, we have a go ahead error there. Last user input, an undeclared identifier. It doesn't know what this is. Hello? It's right here. What's the problem? What's the problem? What do we got here? Oh my gosh, that's a lot of issues, actually. What is it not happy about here? What is it not happy about? Let's see. Engine.h, last user input. Should I leave it like this? Does it not like my declaration here? Oh, maybe I need to instantiate it? Like, or I need to, let's see here. Like this? No? Let's try this build. Okay. Interesting. What is it angry about?
Did you include string?
Oh, I didn't include. Oh, I did include. Yeah, I included string. Yeah.
String at page in the header file.
Oh. There we go. Rock and roll. Okay. Very good. Very good. Thank you. This class needs no help at all. I think you're going to be awesome. Okay. Got a good feeling about this class. Say it's easy. Of course, it's easy, Austin. So we're moving. We're moving, right? Look at that. Look at that. It's working like a charm. Rock and roll. I'm gonna hit quit. Boom. All right. Good. So I think a lot of the difficulty of homework 3 isn't going to come from the actual gameplay logic that you're going to write. You know, don't worry about that too much. The difficulty, I think, is going to be if you're not used to Visual Studio and setting it up and getting the include path to work, right? If you're not useful to doing that on Xcode and Linux, if you're not used to navigating the UIs, a lot of time could get burnt, okay? But the takeaway for today is this. C++ is a bit of a painful language, but you will become very familiar with its quirks, and you'll be able to work around them. You will get a feel eventually for what it wants from you, and when you see certain errors, you'll know how to respond. And so believe that's going to happen. It might be a bit painful. I mean, you just saw me have a little bit of struggle with the include there, right? But you will get there. You'll be working in C++ every day. I struggled with that right there because I haven't dealt with C++ in about 365 days. So I'm a bit rusty. But I hope you'll enjoy it. I hope you'll enjoy working on homework 3 and beating the autograder badly in terms of performance. Good luck with that. Yeah, don't sweat it too much this week, but do start early so it doesn't become more stressful than it needs to be. Okay? Remember those 4 questions. You're going to get some points on the final exam if you just remember those, okay? What are they? Where should you look for headers, and which ones do you want? Where should you look for libraries, and which ones do you want? That's it. Yeah, there's some DLL stuff later. We'll deal with that. No big deal, though. All right, everyone. See you next week. Have a good weekend, and enjoy getting back into C++. I like this language a lot. I think you will, too. Okay? See you later. Okay, everyone online, I hope you enjoyed, and we will see you later as well. Bye-bye.